Hey y'all, we're here for 1.3 and 1.3 looks at different equations of lines. In 1.0 we looked at what is the standard form of a line. In 1.3a we're going to look at slope-intercept form, and in 1.3b tomorrow we are going to go ahead and look at point-slope form. So before we do slope-intercept and point-slope, we need to talk about what actually is slope talking about. So slope is talking about the rate of change in my two variables, my input or my x's and my outputs or my y's. So that rate of change is always going to be what is the rate of change in my y's compared to how fast are the x values changing. A variable that we often use to describe slope in these formulas is m. So hopefully you guys are familiar with that, associating slope with the letter m. And then we can calculate that using this slope formula, where we can take any 2 points on a line. So y1 and y2 and x1 and x2 are just from any point on our line. And we just figure out, again, we're figuring out what is the rate of change. How fast are my y's changing compared to how fast are my x's changing? And a short way that we can represent change is with the Greek letter delta. So this is the Greek letter delta. And we use it a lot in math to mean change. And if you've ever used the program online Delta Math, it's changing the way that you do math, right? It's created an online platform that allows you to check and watch videos. So I think that's probably why they use Delta Math, is because it means change in math. So we have the change in y over the change in x. Okay, so what is the slope of the line that passes through these 2 points? So make sure we're just reading directions. It is just asking for the slope on these two problems. So I'm going to go ahead and use that slope formula. It doesn't matter whether we call this one x1 or x2, but whether we call it x1 or x2, the y has to match. So I'm going to go ahead and call this one x1, y1. We'll call this guy x2, y2. And we will plug that into my slope formula. So m equals y2 minus y1 over x2 minus a negative x1. And we can go ahead and simplify this. Slope equals negative 3 over 1, which is just negative 3. So what that means is that my y's are decreasing by 3 for every time the x goes up 1, is how I would interpret that rate of change or that slope. Okay, so same deal here. Just to prove to you it doesn't matter what order I do these in, I'm going to call this one x2, y2. But notice the 2's have to go together as the same point. I can't mix and match x1 with y2, right? That's not right. I can't do that. Okay, I'm going to go ahead and use my slope formula. Slope equals y2 minus y1 over x2 minus a negative x1. Okay, so again, this means that my y's have a change of 0 as my x's are going up by 7. And it really doesn't even matter how much the x's are going up, because the y's are always going up by 0. Okay, so that kind of leads us into, there are 4 different types or 4 different ways we can describe slope. We can describe slope as being positive. And remember that we always read from left to right, right? So we always read things from left to right. And so that's why we always read slope as going up, because I do know that this left side of the graph is technically going down forever, right? But if we always read from left to right, then this line we would describe as always increasing or always going up. Okay, similarly, when we read from left to right, this line is always going down. going backwards, yes, it does go up forever, but we still say that this is decreasing. So let's go ahead and maybe add those vocabulary words in there. This we would say is increasing. This line here is decreasing because it's going down, or it has negative slope. Okay, and my other two types of slope are zero and undefined. So zero slope is just going to be a completely flat line. That's always going to be the equation of a line y equals something. And then an undefined slope, that is always going to be a vertical line. And that is always going to be the equation x equals something. Okay, so some more facts about slope. Again, being able to identify, looking at whether this slope is positive or negative. So again, reading from left to right, this graph is increasing, so it has positive slope. The slope of parallel lines, well, comparing these two parallel lines, they're parallel because they have the same slope. Right, so same slope for parallel lines. And that leads us into C, perpendicular lines. Well, I can see from this example, one of the slopes, let's call maybe this line y1, and we'll call this line y2. And y1 has positive slope and y2 has negative slope. And additionally, y1 looks much steeper. And I know it's positive, but it still looks a whole lot steeper than y2 does. y2 doesn't look like it's going down as much as y1 is going up. Okay, so the way that we can describe perpendicular slope with those two qualities in mind is that perpendicular lines have opposite, meaning one's positive and one's negative, reciprocal, slopes. And the reciprocal part is what makes one more steep and the second one not quite as steep, as we're going to flip that fraction for slope. So what that would look like is that the slope of M2, or like from Y2 there, so that second slope is going to be -1 over M1, is a mathematical or an algebraic way to show the opposite reciprocal slope. Okay, horizontal and vertical lines, we talked about those with zero and undefined slope. So I would say that this guy definitely has undefined slope. But that's not the question. The question is to write an equation of this line. So obviously in our notes we said that an undefined slope has the equation x equals, but how would you remember that on a test? And what helps me is that if I look at that vertical line and I draw a dot at the intercept, it has an x-intercept. And so what that tells me is this is going to be an x equals equation. Okay, and the reason that that makes sense is because any single point on this line is going to have an x value of 3. I could pick any point and the y value changes, but the x value is always going to be 3. Okay, we can use that same trick for my horizontal line over here. And let's pretend I didn't have that above 2 on purpose. Let's pretend it goes perfectly through 2 right here. Okay, so this is going to be, because it crosses the y-axis, y equals 2. For the same reason, because any single point is going to have the y value equal 2. box that in so we see that's my answer. We can go ahead and box this guy in too. Beautiful. Okay, so that leads us, now that we've talked about slope, that leads us into slope-intercept form. So slope-intercept form of a line is going to be a version of our parent function with some transformations. Okay, and those transformations are going to be changing it based on the slope and changing it based on the y-intercept. So we're going to use m for slope and b for y-intercept. And when do we use this form? This is going to be important later in the chapter, but we're going to use this whenever it's easy to identify the slope and to identify the y-intercept. That's what's going to make this one best. Okay, so we can rewrite a linear equation in slope-intercept form by solving for y. And that's going to be really helpful for graphing it in our graphing calculator, because we know that on our graphing calculator that button is y equals, because we have to graph our functions in terms of y. Okay, so we're going to practice two things here. One, we're going to put these in slope-intercept form by solving for y. And that way we can compare the slopes. We're going to compare the slopes because we need to determine whether these lines are parallel, perpendicular, or neither. So remember, that's going to be, do they have the same slope? Do they have opposite reciprocal slopes? Or do they just have random different slopes from each other? Okay, so let's change this one first. We're going to get the y all by itself, so I'm going to subtract 10x. Okay, so I'm going to go ahead and state my slope is -2, because I need to compare that to what's the slope of my other line. Okay, so I'm trying to get the y all by itself. And sure, I kind of like flip-flopped the sides of the equal sign that it's on, but that's okay. I can still read this as slope-intercept form. Okay, so this slope is -1/2. Okay, and comparing these two slopes together, they are reciprocals, but they're not opposite signs from each other. So this is going to be neither. They were almost perpendicular, but it didn't meet all of the requirements. So it is neither parallel nor perpendicular. Alrighty. B, let's do the same thing. We're going to isolate y so that we can easily figure out what the slope is. Or we can easily identify what the slope is. And remember, we do not like slope to be a decimal. We always want to leave it in fraction form, because the way that I interpret this slope is that the y value goes up 4 every time the x value goes up 3. So that's that rate of change that the slope describes. Okay, oh, this one's a nice one step. We can just divide by -3, divide by -3. Okay, and this is out of order, but I can still read this as y equals b is always the value by itself. M is always the value that's multiplied with the x. So my slope is 4/3. So if I compare my two slopes, those are equal to each other. And if they're equal, that means the lines are parallel. Beautiful. Alrighty, next question. So we need to figure out the slope, and the easiest way to do that is to go ahead and isolate y. Okay, doesn't really look like there's a whole lot of numbers here, but remember we can imagine this x as being multiplied by an invisible 1. So there's my slope for this guy. Oops, let's change the colors of that. Again, there's no number in front of the x, but we know that it's multiplied by an invisible 1, that identity property there. And comparing those two slopes, I do have the same slope, so it looks like these are also parallel. Okie dokie. This one's interesting. So my motive this whole time has been, let's get the y all by itself. And the y is all by itself here, but there's no y in this problem. So a good strategy when you're stuck is maybe let's think of this graphically. Okay, so here's a graph. X equals 5. 1, 2, 3, 4, 5. I put a dot there, and maybe that reminds me, oh yeah, this is my vertical line. So this is the line x equals 5. I'm going to go ahead and use a different color for y. Y is 2, 1, 2. And I can put a dot there, and hopefully that reminds me, oh yeah, this is my horizontal line. And you didn't have to have that memorized, right? I just showed you how you can problem solve your way to getting there on a test or a quiz, or especially the ACT, when it's a review of a bunch of different information. It's a good way for you to figure out what's going on here. Okay, and just looking at this picture, I can tell that those definitely form a right angle, that a vertical line and a horizontal line are going to be perpendicular to each other. And I kind of want to pause for a second, because how is that possible? I told you that perpendicular has to have opposite reciprocal slopes. And I know that the slope of a horizontal line is, let me write that in purple. So my horizontal line is m equals 0, but my vertical line is m equals undefined. Are those opposite reciprocals of each other? So if I think of 0, right, we can rewrite 0 as 0 divided by 1. So the opposite reciprocal of 0 over 1 is going to be negative 1 over 0, right? Reciprocal means I flip it over. And when I divide by 0, that causes my answer to be undefined. So they are actually opposite reciprocals of each other, and that is interesting. Alrighty, write the equation of each line. So this is nice. We have the slope and we have the y-intercept. So if we want to, we can go ahead and say that m is 1/5, which I guess it already said that. But here, b is going to be that y value of the y-intercept, -3. So I just plug that into my slope-intercept form. Y equals mx plus b. Instead of plus -3, I'm just going to write -3. But you could write plus -3 if you wanted to. That is acceptable. Okie dokie. So here I can see pretty easily my y-intercept. My y-intercept is at 0, 4, which means that my b is 4. And my slope, remember it's going to be my change in y over my change in x. So that's going to be, I go down 3. So down 3, and then I go to the right 1, so +1. So -3 is my slope. So we can go ahead and plug those in. Y equals mx plus b. Okay, here I have 2 points. One of them is my y-intercept, right? Okay, so I know that b is 3, because this guy's my y-intercept. Okay, but I'm going to have to calculate slope. Slope is, we can call this guy x1, y1, this guy x2, y2. So y2 minus y1 over x2 minus -x1. So -6/3 simplifies to -2. Now that I have all my information, easy enough to go ahead and plug into my slope-intercept equation. Okay, and D. So this one's kind of sneaky. I have 2 points again, so I know I could calculate slope. Let's go ahead and do that. Okay, so I have my slope. But my y-intercept, remember y-intercept is always going to be 0, whatever the y-intercept is. And I do see that here, 0, 0. So my y-intercept must just be 0, right? So when I write that in my equation, we could write +0 for my y-intercept, or that b value. But adding 0, that's an identity property. I don't really need to write that down. So my equation in slope-intercept form might just look like this. Okay? One example left, 4 parts. Write each equation in slope-intercept form. Okay, so I already have the equation. It's just a lot like example 4, where we need to isolate the y. And then we need to name the slope and y-intercept. Okay, so writing the equation means I need to get the y all by itself. Divide both sides by 2. Remember, we want to leave that slope as a fraction, even if it's an improper fraction. So that means I'm going to go down 3 in my y's every time I go 2 to the right for my x's. Okie dokie, so I have it in slope-intercept form. That was task number 1. Task number 2 is to name the slope. And careful with the y-intercept. It's tempting to just say b equals 9. But remember that we want to format my y-intercept as 0, 9 is the best way to write that. Okay, I'm going to go ahead and I'm going to skip to C, and then we'll talk about B and D next. Okay, two negatives make a positive. Name the slope Bob. Just kidding. That was silly. Okay, and name the y-intercept. Beautiful. Okay, and what was different about B and D? Well, B and D both have fractions, and I don't really like to deal with fractions. So what is an option that I have? Okay, and a nice trick. You don't have to do this if you don't mind fractions. You can just do what you normally would. Add 3/4 x to both sides, divide by 1/2. But we can avoid using fractions by multiplying everything by the least common denominator. So looking at B, I can see two denominators, and the smallest multiple is going to be 4, right? 4 would be my least common denominator there. So if I multiply everything times 4, we've practiced this before. Here, let me actually change this to purple. Okay, I'm going to go ahead and make sure I'm careful to distribute that. Negative 3/4 times 4 is just going to be negative 3. Half of 4 is 2. And negative 1 times 4. And now I don't have to deal with fractions at all. Now I can just go ahead and add 3x to both sides. Divide both sides by 2. And I have my equation in slope-intercept form. From there, I can go ahead and name my slope. Oh, wrong number. And name my y-intercept. Okay, so I'd encourage you, go ahead and try D. See if you can figure out the trick on D on your own. Pause the video. I'm going to go ahead and solve it so that way you can check. Oops. Make sure you distribute that 6 to everything. If you're not sure what 2/3 times 6 is, you're more than welcome to use your calculator. Once we have this, it is so much easier to rewrite it in slope-intercept form. We now have our equation in slope-intercept form. We can name our slope, name our y-intercept, and we are done with the first half of 1.3. I will see y'all in the